So this thesis topic is about the effect of plunger damage from prior firmness measurements on the further course of softening during the ripening process of pome fruits, so that harvest apples and pears will be quite hard, and then they gradually become softer due to their ethylene-dependent ripening process. But when you're buying or selling pears, you don't want them to be soft just yet, and that's why firmness is an important quality characteristic that is being monitored at several testing facilities. So after harvest, the grower will send the majority of his fruit to a storage facility. So those are cooling units in which the fruit can be stored for a long time. But he will also send a select sample of fruits to a testing facility like the VCBT, the Flemish Center for Post-Harvest Technology. And at the testing facility, the firmness will be measured using a penetrometer. A penetrometer is just a machine that punches a hole through the fruit with a plunger, and it measures the amount of force that is needed to do so. This is usually done over a period of 14 days, which is called a shelf life experiment. So the pears are just exposed to ambient temperature conditions. For pears, it is 12 degrees Celsius, and then they see how the firmness will deteriorate. So they not only get the initial firmness, but also how the firmness goes down over a period of time. And those measurements are then put into mathematical models, so that from the shelf life experiments we can actually predict how the fruit will react in storage. And this is done with nonlinear models. Nonlinear models because this firmness development has a sigmoidal shape. It starts off at an initial asymptote that is quite high, and then it accelerates and then decelerates towards a lower asymptote at which the fruits, so the pears, are entirely soft. So that was a brief overview of the testing procedure. This thesis topic is about an aspect of the experimental design that makes a huge difference when it comes to the mathematical modeling. Nowadays, the VCBT uses an experimental design with independent measurements, which means that at different time points, different pear samples are used, so they never have to punch more than one hole in one fruit sample, and so the measurements are independent. But they know that some other testing facilities use a design with repeated measurements. So they use the same fruit and they just punch it several times at multiple time points. But they don't really know what the effect of this plunger will be. They don't know if the plunger damage inflicted at an earlier time point will have any effect on any further time points. And that's what we want to clarify in this thesis topic, because a repeated measurement design has a lot of advantages, because you're then actually modeling a time development of one pear, and the rate of decrease for the firmness of a pear, it will slightly differ. So it's very useful to actually use sample-specific parameters, for example, for that rate of decrease. And it's something that you cannot do when using that independent design, like you can see on the left figure, because you have parameters that are bound to be sample specific. Another smaller part of this project is to use non-destructive techniques for measuring the firmness, like near-infrared spectroscopy and acoustic vibration techniques. These will not give you firmness measurements directly. They will give you spectra data for wavelengths, which you can transform to the firmness measurements. And the advantage of these non-destructive techniques is that you don't actually have to wound the fruit, so it's much easier to have a repeated measurement design. But the problem is that these techniques might not be that accurate when you compare it to the penetrometer, so that's one aspect that you will have to investigate as well. I hope that you get the general idea of this topic from this short presentation, and that I have awakened your interest. And if you choose this topic, then I hope to see you soon.